It is Tuesday, August 16th for Math 1324, and we're going to be finishing up the second half of week 5 homework, problems 16 through 30. That will be the end of working on new homework assignments for 1324. And then we'll have one last video tomorrow on Wednesday, August 17th, that will cover the review since we don't have any new homework to worry about on that third day of the week. Okay, so week 5 homework. Yesterday we did 1 through 15. Today we'll pick up with 16. 16 through 19 are similar to the last couple we did last time, and then 20 puts all this together. So we're solving a system graphically and indicating the solution region is bounded or unbounded. Find the coordinates of each corner point. So x plus y is less than or equal to 6. Again, you can write it down, solve for y, and get the slope and the intercept if you want. But any of these inequalities where everything is positive, especially on these types of solution problems with bounded regions, you can just use the intercept method on as long as they're all positive, which here they all are. So plug 0 in for y, and literally x is 6. So then come over here and put a dot at x is 6. And then if you plug 0 in for x, y also happens to be 6. And it's a solid line, less than, so less than you're going to be shading down. So it's already looking like we're going to be in this triangular region, at least partially. And we do have x is greater than or equals 0, y is greater than or equals 0, so we're definitely going to be putting both of those on. So the x-axis and the y-axis, we're always in the first quadrant whenever they give us both of those two. And then you can do the same thing on this one. It's all positive. If you plug 0 in for y, x equals 8. If you plug 0 in for x, 2y equals 8, so y would be 4. And that one's less than or equal also. So we're trying to go below both of the diagonal lines and stay in the first quadrant. So the region is right there. Okay, so this is a bounded region. It's enclosed entirely. That's bounded, which means that you're guaranteed to get a max and a min. Corner points are right here, 0, 4. And make sure you get that in the correct order, because some people say 4, 0 for that, but this is 0, 4. This is 0, 0 at the origin. And then there's this 6, 0 right here. And then the last one's right there. And sometimes with these kind of graphs, especially if you blow it up, then you can probably eyeball it and tell that that's 4 and 2. 4, 2. And if it's like you're doing it by hand on your own piece of paper and you can't really tell because you have just a sketch of a graph, sometimes that happens. Another way to tell is to solve these first two inequalities either for x or y. Like if I solve both of these for x, move the y over here, move the 2y over there, then you would get 6 minus y and 8 minus 2y. Since they would both be set to x, then you could set them equal to each other. And then you would solve for the y where they are equal to each other. And then you would know that y is 2, and then you could plug it back in to get that x is 4. So that we might do that later if we have one where the graph isn't so nice. So that's all we did on 16, but then later we're going to continue on that, and we're going to check these 4 corner points. One of these 4 is going to lead to a minimum answer. One of these 4 is going to lead to a maximum answer. There's a unique minimum and a unique maximum, but sometimes more than one coordinate could lead to the same min or max, but the mins and maxes are unique, even if there's a tie. Okay, same kind of problem, and I, of course, have my x and y axis again, as most of these problems have. So you can put those two on right away. That's the bottom two. And again, we have all positives here, so I can do the intercept method, plug in 0 for y, and you'll just be left with 2x equals 12, so x would be 6. Plug 0 in for x, and you get y equals 12. So y is 12, and there's a line between them. But that one's greater than or equal to, so that's going to go this way. Same thing on the other one, put 0 in for y, x would equal 12. Put 0 in for x, 2y equals 12, y equals 6. And that one's greater than or equal to. So you're going above both lines. That would be this. And this is an unbounded region because the graph doesn't stop here, just us humans and us pictures that we draw. It seems to stop, but it would continue on forever. There would be you'd need some other line out there to stop it. We don't have any more lines. So the solution region is unbounded because the shaded region, this is their kind of definition. If you cannot enclose it with a circle, then it's unbounded. But to me, it's easier to think that it's just going to keep going forever, because it kind of looks like I could put a circle around this, or even if it got bigger, why can't I make a bigger circle? But, so what are the corner points? So corner points would be when you change directions on your blue line. So I'm coming down and then boom, I just changed directions right there. That's 0, 12. And then I'm coming down right here, boom, we just changed directions right there, and that looks like that's exactly 4, 4. And then there's one last one, boom, right there. Then you would just continue forever. So 12, 0. So when it's a bounded region, then you're guaranteed to get a max and a min. If it's unbounded, then at least one of the two answers will not be possible. If it goes up forever, then there is no maximum. If for some reason you weren't bounded by the first quadrant, that if they took these last two inequalities away, then you could go down forever too, and there'd be no minimum. But we are going up forever. We're not going down forever. We have this limit here that contains us. So that means there is a minimum and there is no maximum. And then the good news is, whether there's both a min and max or just one of them, the corner points are the only places where they can occur. So I could check all three of these corner points to see if there's a minimum, and one of them, at least one, would be the minimum or tied for the minimum. Now we're not doing that yet because we need to be given one more equation to do that, but that's what this is leading up to. Solve the system graphically. Okay, same kind of problem. So I got all positives, and notice I don't have the x is greater than 0 or the y is greater than 0. So now I'm not bounded by the x and y axis. So then there could be no minimum if the graph goes down forever. But these are all positive here. So 4x plus 3y is less than or equal to 36. I can do the intercept method because both 3 and 4 divide into 36. 36 divided by 4 for the x would be 9. And then cover up the 4x. 3y equals 36. Y would be 12. That one's less than, so it's going to go down, but it's not going to stop in this triangle area. It's going to go down forever because we don't have the x and the y-axis stopping us. On the second one, cover up the y. 2x equals 18, so x would be 9. So that's a coincidence that they're both 9, but that's fine. It can start there too, because y would be 18, which is a different y. That one's greater than, so that one's going up forever. And then we also have this as a vertical line. X is less than or equal to 6. So click on x is 6 and then go above or below that anywhere. Okay, so now we got to scroll this down because it can go both ways. We got this spot right there. At 9 is where they're crisscrossing each other. Here's where it might help to do this. right here at 9, 0. One line's going like this, and the other one's going right through 9, 0, 2, but it's higher up. And then we got a vertical line at 6. Okay, so the vertical line is less than, that's the one time you go left or right. So you're going to the left of the vertical line, but you are allowed to go below the X and Y axes. There's nothing stopping me, so that would keep going forever to the left. For the top diagonal line, the one that went through the Y was 12, so that's the lower one. The lower diagonal line is a less than or equal to this one. So you're going down like this. But the other one was greater than, so that one's going up. I need to see where all these are crisscrossing each other, all three at the same time. And it doesn't look like they cross all three at the same time. This area, 2 of them are located. This one's going this way and this one's going down, but this one's going up at that portion. And then even this little wedge right here, both of the diagonal lines are crossing each other. That would normally be a good region if there was 2, but then the vertical line's not going that way. So if they would have made the vertical line go greater than, then we would have had this little wedge right here where all 3 of them were located at the same time. Okay, so let's check. Okay, see, I didn't shade anything because there wasn't any one region where all 3 of them were located. So that means is bounded or unbounded? It's neither, because there's really no solution. It can't be bounded or unbounded unless you have something that you shaded. So that one was really a special case. There are no corner points because we don't have a solution to look at. But again, on that question number 18, if they would switch this X less than or equal to 6 to greater than or equal, then you would be shading to the right on the vertical line. And then you would actually hit this, it would be right in here, because you'd be below this one and above that one and to the right of this one. Then this little wedge right here would have been shaded, and the one corner point would have been right there, 9, 0, and it would go down forever. So there'd be no minimum, and then that one would end up being the maximum. So that could have happened, but they just made that one, no solution, just to show you that can happen too. So on the first 2 inequalities here, notice there's negatives involved. So then I would not use the intercept method. Otherwise you can shade in the wrong spot. X minus Y is less than or equal to 0. Solve for Y so you can get the slope and the y-intercept. And you don't have to put a 0, but I'm going to add it just to have a y-intercept. Divide by -1. I'm dividing by a negative. That's going to flip the inequality. So negative x divided by -1 is positive x. 0 divided by anything is 0. So this has a y-intercept of 0, which is the origin. And then it's got a slope of 1. Or 1 over 1, so you go up 1 and over 1 to the right. So let me put this one here. Y-intercept of 0, up 1, right 1. And the inequality flipped from less than in the original to greater than. So you're going above that line. But if you looked at the original and tried the intercept method, you might have got tricked and thought that one goes down. Okay, so that one's going upward, and then what's the next one? The next one is 2x minus y is less than or equal to 6. 2x minus y is less than or equal to 6. Subtract 2x. I always put the x part first so that it'll line up with mx plus b, and the 2 is negative, the 6 is positive. Now divide by -1. I'm dividing by a negative. So now it's going to flip again to greater than or equal to. Negative 2x divided by -1 is positive 2x. And 6 divided by -1 is negative 6. So these are the two methods to draw these lines. You either solve for y and get the y-intercept and the slope. You can do that in every problem if you want. Or you can do that intercept method, but I only suggest that if you have all positives here, and if both of these two numbers divide into that, which for these word problem type problems we're about to do, that's usually the case. But for this one, I wouldn't do it because there's a negative there. So start at -6 and then go up to over 1. -6 y-intercept. Up to over 1. Up to over 1. Up to over 1. Now these are not parallel because one's got a slope of 1 and the other one's got a slope of 2. So my graph doesn't look great, and it would be hard to see this by hand, but eventually these are going to catch up to each other and cross out here somewhere. And this one is, where do I have it? This one also switched to a greater than. So you'd be shading above that one too. So here's where the computer graph helps more. Let me put these on the computer graph. So the first one had a y-intercept of 0 and a slope of 1, up 1 over 1. The second one had a y-intercept of -6, up 2 over 1. See, they do cross eventually. And you're above the blue line, you're above the yellow line, so that's going to keep you all over here from just these two. But then we also have this, that x has to be between 0 and 10. So that's two vertical lines. That's a vertical line when x is 0, which is the y-axis, and another one when x is 10. So you need to stay between these two. That's this double less, that means between. I need to be between x is 0 and x is 10. I would be between this the whole time, but also above the blue line, the two blue lines in essence now that they're blue. So that would be this region right here. And then that's got a corner point right here at the origin. There's another corner point here, and there's another one there, and it goes up forever. So this is unbounded, no maximum, but there could be, in fact there is, one of these three corner points is going to be the minimum. It's unbounded because it goes up forever. And the corner point 0, 0, the origin's one of the three corner points. And then this one right there is 6 for the x and 6 for the y. And the last one's right there, 10 and 14. So this is section 5 too. When we get to 5.3, we're going to be working with these corner points more. Section 5.2 is about the graphs of these types of problems, and then 5.3 you actually solve them. Okay, a farmer can buy two types of plant food, mix A and mix B. That's going to be your X and your Y. Mix A, mix B. This is the X and the Y variables. Each cubic yard of mix A contains 52 pounds of phosphoric acid. I'll just call that PA, phosphoric acid. There's 52 for each mix A. Mix A, each cubic yard of mix A has 52 of phosphoric acid, 30 of nitrogen. Nitrogen is 30. And 7 pounds of potash, whatever that is, potassium. I don't know if it's like potassium, but potash, whatever that is. Each cubic yard of B. So now we're going to list 3 numbers below mix B. There's 13 phosphoric, 30 nitrogen, and 21 potash. 13, 30, and 21. Do that vertically. 13, 30, 21. The minimum monthly requirements are 520, 900, and 315. Minimum means you have to do at least that much. And remember, at least means greater than or equal to. So we're greater than or equal to 520. We're greater than or equal to 900. And greater than or equal to 315. So it looks like in the answer blanks, they're going to want an equation for each of these 3 conditions. And all you have to do is insert your x's and y's each time. So this is where these inequalities come from when they make you graph them. In all the problems up to this point, they just told you what they were. Now you have to get this yourself out of the paragraph. 52x plus 13y is greater than or equal to 520. 52x plus 13y is greater than or equal to 520. That's what minimum means. You can't be less than that. It's everything but that. Everything but less than, which is greater than or equal to. Okay, for the nitrogen, it's 30x plus 30y equals 900. Or greater than or equal to 900. 30x plus 30y is greater than or equal to 900. And then potash, whatever that is, potash. 7x plus 21y is greater than or equal to 315. 7x plus 21y is greater than or equal to 315. Are any other inequalities needed? So can you have negative amounts of the mix? No, you could put none. I could do none of the x and or none of the y, but I can't do negatives. So that's why these 2 conditions are often in the problem, that x is greater than or equal to 0 and y is greater than or equal to 0. Especially when you're dealing with a word problem where you're trying to do, I need so many of this thing and so many of that thing, they can't be negative. So that in most word problems, those are always going to be there. They had one of the graphing problems where they didn't put them because maybe you're not dealing with a word problem, but when there's word problems, that's almost always going to happen. Okay, so then I would definitely use the intercept method here. Hopefully these divide evenly. So everything's all positive here. All positives right here. So then this is not going to flip. It's going to be greater than or equal to. If I put 0 in for y, this part would disappear. So 52x equals 520. That's going to divide evenly. That's exactly 10. 520 divided by 52 is 10. So x is 10 for my first line. X is 10. And then if you put 0 in for x, this part disappears. 520 divided by 13 is exactly 40 for the y. So y is 40. And that one's greater than or equal to, so it's going to go out this way. In fact, they're all greater than or equal to. Do the same thing here, and luckily these are both 30, so whatever 900 divided by 30 is, that's what they're both going to be. 900 divided by 30 is 30. So the second line, both of the clicks should be at 30. And then finally, 7 and 21, if I put 0 in for y, 7x equals 315. So 315 divided by 7 is 45 for the x. 40, 45. And then you need to put a 0 in for x and get 21 equals 315. 315 divided by 21 is 15. The y is 15 when the x is 45. So there's your 3 lines, and you're greater than all of them. So it's going to be one of these unbounded ones that's out here. You need to stay above this one, and above that one, and above this one. So you're way out here in this region. It's unbounded, so there will be no maximum answer. Maybe they're trying to minimize these. Find acceptable solutions. Okay. It doesn't say about, but usually, oh, it does say minimum right here. No, that's for those. Okay. But I don't think we're solving these yet till the next section, 5.3. But in 5.3, they'll ask you to find either the max or the min or both in all these problems. And this one, if that happened, there would be no maximum. Oh, I forgot my x and y axis is what happened. So the x-axis, we have to be above that. Otherwise, it could be in the negatives. Otherwise the shading would go below the x-axis. And then we need the y-axis. Okay. So I forgot those two. And that was it for that. You're not solving them yet. So now we're in section 5.3. Now we're actually going to solve these. So here's a graph they already drew for you. And this is apparently would be the shaded part. They didn't shade it here. They just put that it's the feasible set. The part that you shade is called the feasible set. And that determines where corner points are located. And if it's entirely enclosed like this one, then you get both a max and a min. Although they might not ask for both of them. So it says determine x and y, so the objective function is maximized. So here they only care about the maximum. The objective function, this is the equation they haven't been given you yet. In section 5.2, they never gave you this. So usually what happens is you get this kind of a deal going on. And then usually there's what's called the objective function that these problems never gave us. And it's usually identical. Either they say it in words like this, or they set it equal to another variable, often z. So if you see z equals something, that's definitely an objective function, 8x plus 2y. And then they have to tell you if they want this maximized, minimized, or both. This one said maximize. And this one wasn't for this problem, but what I'm saying here is that from now on, that we're going to have this given to us along with the rest of the stuff. So this is what was missing in section 5.2. They didn't bother to mention this yet because they were just trying to teach you the graphs first. So now that we're in 5.3, we have an objective function given to us, 8x plus 2y. And normally we would have all those inequalities too, or a word problem where we could figure them out ourselves. But here they're making it easy at first by they already did the graphing part for you, even though you just learned how to do that. So the graphing part's been already done. We have our 3 corner points. 0, 0, 0, 10, and 10, 0. So once you have this knowledge completed, then the way you find the max and or min is you make a little table. So I'm going to put corner points first. A list of your corner points is nice because it's the only place where maxes and mins can occur. It very much limits what we have to check for. In theory, the answer could be anywhere in the shaded part, but the rule is that only corner points lead to maxes and mins. The other parts are just solutions, that they're just not max or mins. And then you do the objective function in the second column. And this is pretty easy to do in most problems. The only way it's not easy is, whoops, I don't know what happened there. It just switched me on its own. The only way that this is not easy is if you can't do the graph. That's why they spent a whole section teaching how to do the graphs. So what's going on here? Computer's acting strange, controlling itself. Okay, so all you have to do is plug in your corner points, however many you have, and that can only be determined if you see the graph, into this objective function. So first I'm going to plug 0, 0 in, then I'm going to plug 0, 10 in, then I'm going to plug 10, 0 in. And this is all easy with a calculator. In fact, 0 times anything is 0, so the parts that are times 0 are going to disappear, which is, you don't always have corner points that have a 0 in them, but if you do, they disappear. In fact, this is 0 plus 0 right here. This is 0 plus whatever 2 times 10 is. 2 times 10 is 20. 20 plus 0 is 20. That's why you don't need the 0 part. And this is 8 times 10, 80, plus 0, but that's just 80. Once you get your list of answers here, whichever one is the smallest answer, or tied for the smallest answer, that's the minimum value. Although they didn't care about the minimum here. Often if 0, 0 is a coordinate of one of your corner points, that's always going to be the minimum, unless it's like unbounded down below it. So 0, 0, if you don't always get that in your shaded portion, but if you do, that's always the minimum. And in many cases, if we're like trying to maximize our profits in a business setting, we don't care about minimizing our profits. We want to make maximum profits. So of course, if we make no mix A and no mix B, if we don't use anything, we don't make any money. So oftentimes like that, the minimum is pointless because, yeah, if we don't do any work, we don't make any money. But here's the maximum value. And this is a generic problem, but if I relate it to number 20, if we were to make 10 of mix A and nothing of mix B, that could potentially maximize our profits. And we could make $80 or $80,000 or $80 million. If it's like a big business, it could be in millions or something. So if the X is 10 and the Y is 0, that's the one spot where you're going to maximize this problem. And you just have to check each corner point into the objective function. Now, there's also a graphical way to do this. If you take your objective function, and here they're calling it P instead of Z, but often it's Z, P equals X plus Y. If you solve that for Y, P equals X plus Y is our objective function that we might try to maximize or minimize. Solve this for Y. And it's all about the slope, actually. The P doesn't matter. This has a slope of -1 right here. A -1 slope is when you go down 1, right 1, down 1, right 1, like this. Okay, so that's the slope, and then it says do the objective function through 3, 3, and 6, 6. Use a straight edge. Okay, well, you don't even, if you were doing it by hand, you'd need a straight edge, but if you go through a solution point like 3, 3 or 6, 6 with a -1 slope, so it's not this, that's not a -1 slope, this is a 0 slope, this is an undefined slope. It's clearly this graph B here, it's the only one that even has negative slopes, and it has one going through each point. This is a graphical way that you don't have to do that table potentially. I could still do the table, and maybe the table's more definitive. If I made a table of corner points, there's 1, 2, 3, 4 corner points. If I do a table of the 4 corner points here, whatever answer has the lowest answer is the minimum spot, and then minimum value, and then whatever has the highest answer is the maximum value. And if there's a tie, that just means that 2 corner points are giving me the same maximum or minimum. So that would be more definitive. But if you draw these lines in here, whichever line, I should say it this way, whichever corner point is closest to these lines, or which way you could move the lines. If I move this line as far to the left as possible, that would be the minimum point. And if I keep moving these, just think of the reason they're putting 2 here is because you can move them back and forth. So any line you draw, if you keep that slope and move left and right, whichever point you touch last on the left, that's the minimum. Whichever one you touch last on the right would be the maximum. So if you're going to the right, see how this line's already bypassed that point. If you kept going, it looks like you would bypass this point first, and then you would touch that point last. So that's what these are, kind of like visual. If I move them left and right, which point do I touch last on the left? Which one do I touch last on the right? That's the max and min. So apparently 0, 0 as usual would be the minimum, and then apparently this corner point would be the maximum visually. Now sometimes it's a little hard to tell, especially on these tiny graphs, but that's another method besides the table method. So what are the coordinates of the corner point where the maximum profit occurs? It must be this one here, which apparently is somewhere between 5 and 10 for each of them. So it must be this 7, 8. It's definitely not 0, 0 or 0, 13 or 10, 0. And now here's the table method to prove it. So this will confirm your answer. You can do both if you want, but normally you do one method or the other. So 0, 0, that's definitely going to have a 0 answer, and that's definitely the minimum. And then all I'm doing is plugging them into x plus y. So 0 plus 0 is 0. 0 plus 13 is 13. 7 plus 8 is 15. And 10 plus 0 is 10. So remember last time they had like, what did they have? Last time they had 8x plus 2y. Then you have to do a little bit more calculating. But if it's just x plus y, you're literally just adding the 2 corner points together. So yeah, 7, 8, that did have the maximum answer. So that's the only point here, is that you can maybe tell the answer graphically a little quicker than you can tell by the table method. But the table method is going to be definitive. Clearly 15 is the highest answer in the objective function, and that means 7, 8's the only corner point leading to that maximum. If there's a tie for the highest, then you just have 2 points that lead to the maximum, but there's still only one maximum value when that occurs, 15 or whatever it turns out to be. Okay, same deal here. The graph's easy because they're being silly and they're not even giving you 2 possible graphs. So unless you had an objective function that only had x or y in it, which I've never seen, then you're definitely going to get these 2 diagonal lines like this. It's not going to be one diagonal line. It's not going to be vertical line. It's not going to be horizontal. It's definitely this one. But if you solve for y here, you would subtract 7x and divide by 3. So that's negative 7 over 3. So the slopes are actually negative 7 over 3. So if I slide this slope left and right, clearly the furthest point to the left at that slope is 0, 0. And then furthest to the right is definitely not that one. I've already passed it up right there. So that might be a little hard to tell. Am I going to pass up? Which of those 2 am I going to pass up first? Whichever one you don't pass up first, that's the maximum. And maybe there's a tie because they have, every choice has 2. So remember I said it was kind of hard to tell which of those 2 was I going to pass up first. If I move this slope to the right, maybe this line is also a negative 7/3 slope. It's not possible to tell without them telling me what these are, but by process of elimination on multiple choice, it must be both of those. So a little bit past 10, 0, and then something that again is between 5 and 10 for each of the x and the y. So apparently that's 11, 0. And it's not 0, 0, that's the minimum, so that's out. It's not 0, 9 because both the x and the y are between 5 and 10. So the only way you can do this one is just estimating, and then that one must be A. So this is where there's a tie for the maximum. Both 11, 0 and 8, 7 give me a tie for the maximum value. Because apparently this this line right here must have the same slope as these. So if I slide them to the right, it's going to land right on top of both of them. So it's not going to bypass one of them and leave one as the winner. But now I just got to plug 0 in for X, 0 in for Y, which would make both of those 0. 0 plus 0 is 0. If X is 0 and Y is 9, I only have to put 9 in for Y. 3 times 9 is 27. The ones with 0 in them are nice. Like 11, 0, then you only have to plug in for X. X is 11. 7 times 11 is 77. And then for the 8, 7, you have to do 7 times 8 plus 3 times 7. 7 times 8 plus 3 times 7, and apparently this is going to equal 77 because the graph said that there's a tie here. See, 77. So we have a tie for the maximum. Both 8, 7 and 11, 0 would give me a maximum profit or whatever. This is just a generic problem, but it actually does say maximum profit actually. So if you want to maximize your profit, then make 8 pens and 7 pencils, or 11 pens and no pencils, or if it's about mix A and mix B and a fertilizer, whatever the problem happens to be about, whatever your company does. But if you make 8 of the X and 7 of the Y, or if you make 11 of the X and none of the Y, you'll maximize your profit of $77, or $77,000, $77 million, whatever your business is. Okay, so once again, the graphs are easy. You're never going to pick a horizontal, a vertical, or a single diagonal line. It has to be this one. So if I move, notice 0, 0 is not a spot anymore, so that can't be the minimum. But if I'm moving at this slope, left and right, what's the last corner point I'm going to touch to the left? There's a clear one right there. That one right there is the furthest to the left you're going to go, because this diagonal line has already bypassed all the other corner points. And then as I'm going this way, this one has already bypassed all the corner points except that one. So that's got to be the maximum. The maximum's there and the minimum's here. This one's a clear one to tell even from the graphing method. So the minimum is when both X and Y are a little bit less than 5. It's nothing with a 0 in it, so it must be this 2, 3. The only way 0's in it is if you're on the X or Y axis. And then, okay, I guess we only care about the minimum this time. Now we're trying to minimize costs. We don't care about the maximum. So we don't want to have a maximum cost that's going to eat into our profits. We want to minimize our costs. You always want to minimize costs and maximize profit if you're a business. So 2, 3 is the minimum. It probably would turn out that 15, 15 is the maximum if I was doing that, but we don't care about that here. Although if we're doing this table, they're going to make me do each one. So anything with 0 in it makes that part disappear. So for the first one, you just need 8 times 15. 8 times 15 is 120. So if you make nothing of your first product and 15 of your second product, maybe you make pencils and pens. So I'm a company that makes pencils and pens. If I make no pencils and 15 pens, my costs are gonna be 120 whatever units. Costs could be like labor costs with my employees or insurance or the rent of the store. 15, 15. So you need to do 9 times 15 plus 8 times 15. Although clearly this is not the minimum one. 9 times 15 plus 8 times 15. Then the costs go up to 255, whatever, hundreds, thousands, millions, whatever it is. Then I just have 15 for the X only and nothing for the Y. 15 times 9, 135. Oops. Okay, 2 and 3, this was the minimum. So this should end up being the smallest answer here. 9 times 2 plus 8 times 3. 42. And finally, nothing times X and 10 times 8. 10 times 8 is 80. So yep, the 2, 3 corner point did have the smallest cost. So if I want to minimize my costs, I should make 2 pencils and 3 pens every hour, every day, whatever whatever it's based on. Okay, so that's the end of the graphing method. Now we're going to do our own problems, and I guess you could either graph or do a table or both. Here's our objective function, p equals 20x plus 85y. In other textbooks I've used, they always put z for the objective function, but apparently this textbook likes to use p. P equals 20x plus 85y. All I have is one main inequality, and then of course I'm in the positive first quadrant because we can't make negative pencils and pens. And we're trying to maximize our profits. Maybe that's why they like P, maximize profits, although sometimes it's minimizing costs. So now we don't care about a minimum. And then we have one inequality. And this is where if you're doing it by hand, it's sometimes hard to tell the corner points. This is 24, 25, this is 25. My only main inequality is x plus 7y is less than or equal to 14. Later they'll give me more of those. X plus 7y is less than or equal to 14. So this, you could do the intercept method. There's all positives here. Plug in 0 for y, and x would be 14. Plug in 0 for x, and 7y equals 14. Divide by 7. Y would equal 2. (14, 0) and 0, 2. And you need to be above the x-axis and to the right of the y-axis and stay below this one. So the feasible region that you would shade is this little triangle region. And that means both of these intercepts are corner points, and so is the origin. We only have 3 corner points. It's a bounded region, so we're guaranteed to get a max and a min, although we don't care about minimums here. We're trying to maximize our profits. What's our max profit if the function we work with is 20x plus 85y? So again, you could possibly do the graphing method, but especially by hand, that might be more difficult. I would definitely make your table of corner points. This will be definitive anyway. Corner points, and then the p function goes here, the objective function. And 0, 0 is an easy one because 0 times 20 is 0, 0 times 85 is 0, 0 plus 0 is 0. That's definitely the minimum, but we don't want to minimize our profits. If we make no pencils and no pens, we make no money today. That makes sense. So if you want to make money, you better make some product. So 0 and 2, if I make no pencils and 2 pens, I'm just making that example up, 20 times 0 is 0, 2 times 85 is 170. Now our profit's $170 if we only make 2 pens. Or what if we go 14 and 0, 14 pencils and no pens, 14 times 20, 280, plus nothing for the pens, there's the maximum. So we can maximize our profits if we make 14 pencils and no pens, and we would make a maximum profit of $280, $280,000, $280 million, whatever the business setting is, but we don't need to worry about that here. The maximum profit is 280. And then they might ask, where did that happen at? What x and y? What are the coordinates where that happened? 14 and 0. Or remember that other problem said x is 14 and y is 0. You filled in 2 different blanks. But this one asks for a coordinate, so then I put it in coordinate style. So that's how 26 through 29 work. 26 is just like 25. (4x plus 7y is greater than or equal to 28). And then we also have the positive x and y axis. So let's do the intercept method here. Plug in 0 for y, you would get 4x equals 28. X would be 7. Plug in 0 for x, 7y equals 28. Divide by 7, 28 divided by 7 is 4. Y would be 4. And you need to stay above the x-axis to the right of the y, and this is greater than, so it's this region right here. It's an unbounded region. So it has no maximum. And there's only 2 corner points, these two. The origin's not a corner point. It's not in the shaded region. So there's no maximum because it's unbounded upward, and then one of these two would be the minimum. Now, if I'm trying to maximize profits, I won't be able to. If I'm trying to minimize costs, then one of these two would be the minimum. We are trying to minimize costs. C stands for cost. Minimize costs, 7x plus 11y. So I just need to make a table with 2 corner points. Zero 4 or 7 0, whichever of these two comes out to the smallest answer is my minimum. And then maybe it's like how many daytime employees and how many nighttime employees should I hire to minimize my costs. So I'll just put C here. 0 times 7 is 0. 4 times 11 is 44. 7 times 7 is 49, plus 0 is 49. So the 0.4 is the minimum. I can minimize my costs at 44 units if I have nothing of the first variable and 4 of the second variable. Coordinates would be 0, 4. Okay, only thing different here is we have 2 main inequalities plus the positive x and y axis, and we're back to maximizing. Maximize your profits, 9x plus 9y, and you have 2 main inequalities to do. Maximize profits, 9x plus 9y. The first main inequality is 2x plus y is less than or equal to 30. It's all positive, so I can do the intercept method. We're definitely in the first quadrant only. So if y is 0, 2x would equal 30, x would be 15. And this may or may not be a corner point. Just because it's on your graph doesn't make it a corner point automatically. And then if you plug 0 in for x, y would be 30 way up here. Less than means you're going down, so far we're inside this triangle right here. But now there's a second one, x plus 2y is less than or equal to 24. Plug 0 in for y, x would be 24, which I should have left some room for that maybe. And then plug 0 in for x, 2y equals 24, y would be 12. So this line goes like this. And this one's less than. So you're below this diagonal line and below that one and within the x and y axis, so the shaded region's right here. It's enclosed, so there is a max and a min, and the min's definitely going to be the origin since that's part of the shaded region, but we don't care about that anyway. So when I make my corner point table, and I'm working with P, 0, 0 is going to lead to an answer of 0. And that's definitely the minimum. We don't care about that one. 0, 12, 15, 0. Both of those touch the shaded part. But notice 0, 30 and 24, 0 don't, so they're not in my list. But there's one more corner point that's hard to tell from my graph right there, where these two meet each other. And maybe if I had a computer graph, I could eyeball it, or maybe if I used graph paper, I could figure it out. So there is an algebraic way to tell. You solve these either for x or y. It really doesn't matter, it's whatever is easier. Neither one is easier because there's a 2 here and there's a 2 there. We had one earlier where they were both x, 1x's, then I would solve for those, but here it really doesn't matter. So if I solve this equation for y, it would either be negative 2x plus 30 or 30 minus 2x, however you want to write that. Move the 2x over, make it minus 2x. Solve this one for y. 24 minus x. Divide by 2. And it really isn't about the less thans, it's about the equal to's. So when do these two things equal each other? I could reduce this to 12 too. When does 30 minus 2x equal 12 minus x over 2? And if you don't like fractions, multiply everything by the denominator of 2, and then you won't have fractions. 60 minus 4x equals 24 minus just x, because the 2's would cancel. Add 4x. Negative x plus 4x is 3x minus 24. 36. Divide by 3, x is 12. So that corner point has an x of 12. And these should come out evenly all the time for these word problems. 12. And I can figure out the y by plugging that back into either of the two original ones, even up here. So if you put 12 in, I wouldn't put it in the fractional one, but put 12 right there. 2 times 12 is 24. 30 minus 24 is 6, so the y is 6. So as soon as you get a second diagonal line, then you get harder corner points to find. It's easy when there's only one diagonal line because the intercepts are the only corner points possibly. 2 or more diagonal lines, then you start getting spots where they cross each other. So if you didn't know 12, 6 was a corner point, it might not matter if it doesn't turn out to be the maximum. But if it is the maximum, you would never get it without knowing how to find that corner point. So 0, we'll make that go away. 9 times 12. 108 is the profit if I have 0 of my first item and 12 of my second item. Or if I make first 15 of the first item and nothing of the second item, 9 times 15 is going to be larger than 9 times 12. 135 is my highest so far. But let's see if this one's even higher. 9 times 12 plus 9 times 6. $162, that was the highest. So we can maximize our profit of 162 units if we make 12 of the first item and 6 of the second. Make 12 pencils and 6 pens, and you'll maximize your profits of $162, for example. So 162 is the maximum profit. And it occurred at the coordinate 12, 6, which was the hardest corner point to find. Okay, now we're same kind of deal on 28. There's only 2 inequalities. So we're trying to maximize and minimize. This is the first time they've said that. See how they have the Z now? So it's when you're doing both, that's when they like to use Z. Z equals 4x plus 5y. And you're trying to max and minimize that. So now, when we make our table, we're going to look for the lowest and the highest answer. We have two main inequalities plus our positive x and y axis. So 2x plus y is greater than or equal to 20. And x plus 2y is greater than or equal to 16. Okay, so if I put 0 in for y, 2x would equal 20. So divide by 2, x is 10. Put 0 in for x, y equals 20 directly. Here's the first line. It's greater than, so you would be shading up. We might have an unbounded, no maximum situation. Put 0 in for y, x would be 16. Put 0 in for y, or x, and then y would equal 2, y would equal 16, y would be 8. You're above both of these. And you're in the positive first quadrant too. So it's an unbounded region. There's no maximum. And there's 3 corner points, 0, 20. That touches the shaded part. 0, 8 does not touch the shaded part. 10, 0 doesn't touch the shaded part, but 16, 0 does. And then, of course, there's that one too. So we'd have to figure out what that one is to have a third corner point. And that would be where the two cross each other. So we definitely have 0, 20 and 16, 0. And then there's one more where they cross each other. And I can go ahead and calculate this quick. 20 times 5 is all you have to do there. 20 times 5, that's 100. 4 times 16 is 64. That's the smallest so far. So the only question is this one smaller than 64 or not? There's no maximum, and then the minimum's either 64 or whatever this one is. Or maybe there's a tie. So when do these equal each other? You're going to have to solve for y again, or x, whatever you think is easier. Here it doesn't really matter since there's both of them have a 2. So y would be 20 minus 2x. And then this y would be 16 minus x. And instead of dividing this one by 2, I'm going to multiply this one by 2 so I don't have fractions. 2y equals 40 minus 4x. If they're both equal to 2y, then they're equal to each other. So they're both equal to 2y. That means this expression's equal to that one. 40 minus 4x. I guess I need some more room. 40 minus 4x would have to equal 16 minus x. And then I can solve for the x when this happens. When do these two lines cross each other? When they're equal to each other is when they cross each other. 40 equals 16 plus 3x again. Minus 16. That's 24. So x equals 8. And y equals, you can either put an 8 here or an 8 there. You'll get the same answer either way. This side's easier. 16 minus 8 is 8, so y would be 8. But even if you plugged it here, 4 times 8 is 32. 40 minus 32 is also 8. So the final corner point is 8, 8. That's where these cross each other. So 8 times 4, can't even read it now, I wrote over it. Was it 4x and 5y? Yeah, 4x and 5y. So 8 times 4 and 8 times 5 and add them together. 8 times 4 plus 5 times 8. I messed that up. Okay. 4 times 8 plus 5 times 8. Is it higher, lower, or equal to 64? It's higher than 64. So sometime, last time that missing corner point, the hard corner point to find, was the answer you're looking for. Now it wasn't. So if somebody didn't know how to find it, they would have maybe guessed that the minimum was this one, and they would have got the answer right this time, but you would have missed problem number 27 doing that. So you can't really tell till you find that extra corner point. 64 is the minimum. Maximum, there is no maximum because it's unbounded upward. And there is no maximum, so I don't need a corner point. And then there is a minimum of 64. 16 times 4, 32, 64. 32 plus 40, yeah, That was definitely 8, 8. And, that's weird. 16 times 4 is 64. 4 times 8 plus 5 times 8. That's weird. What is the minimum value? That was the value I had. Let's see what they say. 52. Did I miss a corner point? 52. 20x plus y is greater than or equal to 20. X plus 2y is greater than or equal to 16. 52. Okay, so I gotta see what they say this is. How is that not 8, 4? Where's that one? 8, 4. I don't see where they're getting 8, 4 from. See, there's the 3 points we had. Okay, so 20 minus 2x, did I read it right? 40 minus 4x. 20 minus 2x and 16 minus x. That's already 2y. 40 minus 4x, 16 minus x. 3x, 40 minus 16 is 24. By 3, x is 8. How is y 4? 16 minus 8 is not 4. And 40 minus 32 is not 4. Oh, I know why. Okay, I know what I'm messing up. 2y. Remember, I let them equal 2y just for the convenience of avoiding a fraction. So I didn't solve for y, I solved for 2y. So I should have known this was 2y. So yeah, y is 4. Sometimes you have to get it wrong to see what your mistake is. So the x was 8, the y was supposed to be 4. But actually it was good that you saw this, because this could have happened. It's not always that the hard corner point is the minimum or maximum you're looking for. These two examples, it turned out it was. But yeah, I forgot that I set these equal to 2y. So I needed to divide my y by 2, and y, they are right that y is 4. So my corner point was wrong. This should have been a 4, and that does affect this. So it should have been 4 times 8 plus 5 times 4. So they are correct that the minimum is 52. So be careful about that. If you set them equal to something else, like I did just for convenience, then you got to account for that at the end. So maybe we'll see that here on 29 too. Okay, so now I know what I did wrong there. Okay, now we've got three of these things. We're trying to only maximize 30x plus 40y. Maximize our profits. 30x plus 40y. So now we don't care about the minimum. All of these are less than, so it looks like we're going to get a bounded region. 2x plus y is less than or equal to 12. So plug 0 in for y, 2x is 12, x would be 6. Plug in 0 for x, and y would just be 12 directly. Here's the first of 3 of these diagonal lines, and everything's less than, so we're coming down in this triangular region so far. X plus y is less than or equal to 8. So that both of them are 8 then, so 8, 0. And 0, 8. So now we're in this little quadrilateral slot, but then there's going to be a third one. X plus 2y is less than or equal to 14. X plus 2y is less than or equal to 14. If you put 0 in for y, you'll get x is 14 way out here. Put 0 in for x, 2y is 14, y would be 7. Now, it may or may not be that they're all crossing at that spot. So now it's a little hard to tell by hand. Does it cross exactly there or not? Or is there more than one cross point? But let me just draw it that way for now. And then we're definitely below everything. So we're definitely in this region here. And often when 0, 0 is a corner point, then that's when they don't care about minimums, because obviously that's the minimum. So we've got three or four corner points. There's definitely 0, 7 and 6, 0. Zero, 7, and 6, 0. And then I can't tell from my sketch if that's 1 or maybe 2 points. Maybe one line, 2 lines might cross like this, and the third one might go something like that. And then you could have, if you're below everything, well then maybe it is just that one, but it's possible you could come in a situation where you hit this and then hit that. There could be 2 of them in some cases. So what we're going to have to do is solve each one of these for one variable to tell. And probably y would be well, it's about the same either way, because there's, again, 1, 2x and 1, 2y. Doesn't really matter. So I'm going to solve for y. When do these two cross each other? And this will be easier because I have them both equal to y without any fractions. So when does 12 minus 2x equal 8 minus x? 12 minus 2x, when does that equal 8 minus x? And these are equal to y, so this will be a direct answer. Add 2x. And subtract 8. X is 4. So if all of them cross at the same point, then they should all give me the same y if x is 4. So we could even try that. If x is 4, do the y's all come out the same? If so, there's only one corner point there. So that would be 8 plus y equals 12, and you'd subtract 8, y would also be 4. And here, clearly 4 plus 4 is 8. Subtract 4 from this one, you would get 10. 2 divided into 10 is 5, so they don't all cross at the same point. So one of that last line that goes through 14, that one doesn't cross at 4, it crosses at 5. Okay, so that means there could be 2 corner points there, but 4, 4 is one of them. So here's another strategy we could do, because my only other option is now set these equal to each other and then set those equal to each other to see when they all cross. So let me do this. Let me make a better graph. Use graph paper or a better graph. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that one that was right here, x plus y equals 8. That one's got a y-intercept of 8 and a slope of -1. So you need to go down 1 over 1 repeatedly. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. There's the 4, 4 point right there. That one and this one both cross there. So if you start at 12 and go down 2 over 1, 9, 10, 11, 12, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, got the right 10, 8, 6, 4, right there. Those two definitely cross at 4, 4, because I figured that out algebraically. This is the 4, 4 point. So the third one is the only one I haven't figured out what the y equals would be. 14 minus x, divide by 2. So this would have a 7 y-intercept, and it would have a slope of -1/2. So if you start at 7, down 1 to 6 over 2, down 1 over 2. See, that one crosses it, or it goes through the point 4, 5. But down 1 over 2, that one seems to land right there on that one. So that's the other corner point. There's the 4, 4 right here. And then, of course, there's that 6, 0, and this one, 0, 7. 0, 7. 6, 0 was supposed to be this one. 4, 4 is that one right there. And then these two cross each other right there, which from 7, I went down 1 to 6 and over 2, so that's 2, 6. And you're below every line, so you got to stay there and there. Those are the 2 corner points you're going to touch. This spot and this spot. Where these 2 lines cross each other doesn't matter because it's not in the shaded part. This line right there doesn't touch that spot. So that's the other 2 corner points, 2, 6, and 4, 5. I wasn't sure if we would get 1 or 2 of them, but there is 2 there. That's hard to see unless you look at the graph closer. 4, 5. I tried this to see if they were all the same. If they were all been the same, that would have made it a little easier, but okay, so now we just plug 7 in for y. 40 times 7 is 280. These are my profits. Plug 6 only in for x. 30 times 6 is 180. Then I need to do 30 times 2 plus 40 times 6. 30 times 2 plus 40 times 6 is 300. That's the highest so far. Finally, 30 times 4 plus 40 times 5. 30 times 4 plus 40 times 5. 320, there's the winner. We can maximize our profits of 320 units if we make 4 of our first item and 5 of the second. Maximum is 320. Okay, so 4, 5, 4, 5, 8, and 5 is 13. So maybe I'm wrong about where that crosses. So let's do this again here. The 3 inequalities are 12 minus 2x, let's write it this way, negative 2x plus 12, negative x plus 8, and negative 1/2 x plus 7. These are the 3 equations. Solve for y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to try to do each of these at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. Okay, so this one starts at 12 and goes down 2 over 1. The other one starts at 8 and goes down 1 over 1. And this one starts at 7, down 1 over 2. Okay, go back to this one, down 2 over 1. See if you get, if it helps if you have graph paper, you can keep these vertical of each other. And this one is down 1 over 1. They definitely both cross there. This one and that one cross right there. That is 2, 1, 2, 3, 4, 5, 6, 2, 6. That one's definitely 2, 6 right there. 2, 6. Okay, so that was the 7 and the 8. The 7 and the 8, we figured out where they crossed each other. Okay, so now the 8 one goes down 1 over 1 right there when it's 3. Down 1 over 1 when that one's 4. Okay, the 12, let's do that one next. Down 2 over 1. Down 2 over 1. That's the one that crosses also at that point. And the 8 one does too. So this is 4, 4. Is that what that is? 4, 4. Yeah, 4, 4. That's when the 12 and the 7, 12 and the 8 cross each other. So the only question is, when does the 12 and the 7, when do they cross each other? And maybe I should just set those equal to each other. Negative 2x plus 12 equals negative 1/2 x plus 7. You could double it to negative 4x plus 24 equals negative x plus 14. Add 4x. 3x, subtract the 14. Okay, they don't cross at an exact spot. That's what's messing us up. Okay, divide by 3, 10 over 3. X is 10 over 3, which is a little past 3. The only question is that in or out of the feasible region? Did I have 4, 4 and 2, 6? No, I had 4, 5. That's what's wrong. So this should be 4, 4, I'm guessing, because I'm guessing that 10 thirds, another possible corner point is when X is 10 thirds. And then the Y is probably a fraction too, but usually you don't get fractional answers here because these are how many pencils and how many pens. I can't make 10.3 pencils. So that's where I think I messed up, is I thought that was 4, 4, but 4, 5, but I think it's 4, 4. So 30 times 4 plus 40 times 4 is only 164. That's weird. How did it, when I typed that in before? 30 times 4 plus 40 times 5. Yeah, okay. 30 times 4 plus 40 times 4. Okay, that's better. 280. I didn't think it should drop that much. 280. So that is not the maximum. So apparently the 300 is the maximum. 300. There we go. See, this is hard if you don't have graph paper to see where these things are crossing each other. And that was, which coordinate was that? That was the 2, 6 coordinate. 2, 6. Okay, last one is kind of putting all this together in one problem. This is going to be similar to problem number 20 also. Remember the one with the fertilizer A and fertilizer B? So we've got a class trip going on. We need buses and vans. Buses and vans, that's the X and the Y, like fertilizer A and fertilizer B. Buses and vans. Each bus can transport 54 students. Bus, 54 students. 2 chaperones. And costs $1,400 to rent. So that's the rent. Each van transports 9 students, 1 chaperone, and $90 to rent. There are 432 students in the class that can go, and officers must accommodate at least 432 students. At least is greater than or equal to. So one of our requirements is that 54x plus 9y, that has to be at least 432. Only 24 parents have volunteered, so the officers must use at most 24 chaperones. At most is less than or equal to. 2x plus y has to be less than or equal to 24. How many vehicles of each type should the officers rent in order to minimize costs? We just want to minimize costs. What are the minimum costs? So it's only about minimum, and this money is what we're trying to minimize. So this is, there's no inequality for this one. This is the C, try to minimize costs. That's the objective function. And of course, you can't have negative buses or negative vans, so we are going to be in the first quadrant. But we just have two diagonal lines, so they're only going to cross once at the most, so therefore there's going to only be one hard corner point to find. So if I put 0 in for y in the easier equation, 2x equals 24, x would be 12. Y would be 24 if you put 0 in for x. That one you're going below it. Then 50, if I put 0 in for y, 54 into 432. 432 divided by 54, that would be x is 8. Guess I should have left more room for that. Let me do it here. So 1x is 8, 0, and the other one is 12, 0. Then put 0 in for x, 9y into 432. 432 divided by 9 is 48. So 24 and 48 are my two y-intercepts. We'll call this one 0, 24. And here's 0, 48. The 0, 48 goes through the 8. And the 0, 24 goes through the 12. And you, of course, have to be in the positive x and y axis because you can't have negative vans or buses. So we're in the first quadrant, and we are below the 24, but we're above the 48. We're below the 24. But we're above the 48. Right there. It's this little triangle right there. So we've got 8, 0, we've got 12, 0, and then we got whatever this is, where they cross each other. Those are going to be our three corner points. 0, 0 is not there, and that makes sense because it was never going to involve the origin. Otherwise, it would say get no vans and no buses, and that would minimize your cost, but unfortunately there would be no trip either. So that's why that one's not part of the feasible region. Corner points, and we're trying to minimize costs. 8, 0 and 12, 0. And clearly 8, 0 will have a smaller answer than 12, 0 will, because 12 is bigger. But the corner point here might be the smaller one than 8, maybe not, it's hard to tell. So where do these things cross each other? Probably best to solve for y in each one. So if I solve for y here, it would be 24 minus 2x. If we solve for this y, it would be 9y equals 432 minus 54x. And those both divide by 9 evenly. If they don't divide evenly, then I would try to eliminate the fractions and hope not to make the same mistake I made on 28. But both of those divide evenly. That's 48 again, and this is 6. So I can write y equals 48 minus 6x. And that way they're both equal to y, so I don't have to adjust at the end like I missed out on number 28. And I can just set them equal to each other and see where do they cross each other. And since we don't have a third line to worry about, then this is the only possible extra corner point. If there was a third line coming in, it could cause to have a second extra corner point. So I'm going to add 6x. That would be positive 4x. Subtract 24. That is 24. Divided by 4, x is 6. X is 6 at this corner point right here. And y, we can find it by putting a 6 in to either here or there. It will work in either one. And we could do it both just to double check. So 24 minus 2 times 6 is 12. Does the other one equal 12 also? 48 minus 6 times 6, 12, yep. And they're equal to y, so then it is actually 12. If it was equal to 2y or 3y, then I would have to divide by that too. That's the step I missed on 28. So x is 6 and y is 12. There's my other corner point. And our objective function is 1400x plus 90y. That's what we're trying to minimize our costs with. because buses cost $1,400 to rent and vans are $90 to rent. So 1,400x plus 90y. If we do 8 times 1,400 in the first corner point, whoops, I put 85, sorry. That's $11,200 they would have to raise to be able to afford to go on the trip. Or 1,400 times 12 is clearly going to be larger, 16,800. Or if you do 1,400 times 6 plus 90 times 12, is this less than 11,200? If so, that's the best way to do this. And it is less than that. So they could minimize their costs, even though it won't be as comfortable. Get 6 buses where you can spread out and then squeeze people into vans, 12 vans. You'd squeeze a lot of people into a van. They probably would prefer to have all buses and just be a more comfortable ride for everybody. But if they're trying to save money, then unfortunately you got to get some vans too. So 6 buses and 12 vans is going to be your best way to minimize your costs. The cost would be less than $10,000 that way, $94.80. If you get 6 buses and 12 vans, it'll only cost $94.80 instead of over $11,000. And these kind of trips, either people are paying for it themselves or they're doing like a fundraiser to raise the money for it. So then you got to live with a little uncomfortability in order to have a good trip and get everybody that wants to go. Okay, so it's going to say I missed 28, but I had to get it wrong to see what I was doing wrong. So if I was caring about a good homework grade, if I don't, I can keep my 98 if I'm happy with that, or I could try this one again. And then now I know what I was doing wrong, so I could possibly do that right again. But the video's already over an hour and a half, so I'm not going to redo number 28. But 28, that was, I got tricked by the 2y's. I forgot that I had them set to 2y. See here, they're both equal to y. But when they were equal to 2y's, I should have divided by 2 after that. And I didn't divide by 2 as well, went wrong. Okay, so now we're all done with homework. Save this. And homework's all done now, even though I lost a couple points for that, but I definitely messed up there, so we're done with that. So the review for the final is tomorrow's video. There's 25 questions, and it's kind of like one from every section. So we'll have a video tomorrow that'll cover those, and then we'll just be studying and taking the final. So see you tomorrow.